Hi everyone, and welcome to this YouTube channel. My name is Penny, and this is Penny's Coding Bits. In this video, we are going to talk about TypeScript, which is a superset of JavaScript, and it allows for an optional static typing, which lets developers to specify types for the variables, function parameters, and return values in their code, which then allows for a lot of the programming errors to be detected long before the program is run. So I had come across this programming language in this toolkit that generates AI applications using Llama Index with low code. And for those of you who are interested, you can check out this X post in the description box below. Now let's jump into an example. So here I have specified a dictionary of variables that are related to a book, and that includes the title, the author, and the number of pages. And here I am specifying that the title and the author must be of the string type, and the pages must be in numbers. And when I'm specifying the display book details function, I'm saying that any book related information must comply with this interface. So when I'm passing any object to this function that does not comply with this interface, then it will throw an error and notice that I haven't run this code. Otherwise, there would be a green bar along the left side of my panel. But still, I'm getting this data type error that says type string is not assignable to type number, which pages should be. So this is just a simple example that shows you how powerful the static type checking functionalities within TypeScript is, because most of the coding language that we use today, such as Python and R, do not have this functionality because they are dynamic type languages. So, talking about dynamic type languages, let's show a dynamic type checking example. So, in the dynamic type checking example, we have a process payment function of the parameter amount to be of the type any. So this allows amount to be any type essentially. So we need a dynamic type checking line here to make sure that amount is indeed a number before processing. And notice this is different from our static type checking example where we have specified what each variable should be to begin with. Here, we don't have that, therefore, we need to have this line. And if we have an object that's passed to this function that violates this condition, then we get an error saying that the payment amount is invalid and a number is required. But this is only after this function is run and we have an output from this program. So I hope this is helpful for those of you who want a comparison between static and dynamic type languages. I'll see you in the next video.